So good morning beta. Today we will discuss our chemistry part test 12th, and one by one we'll go from question number 51 to question number 75. You be with me for half an hour and 45 minutes. Let's see one by one. My name is Navneet and we will go through one by one all the questions. So first question, see. So let's say we have a double bond and COCH3 here, and it can be oxidized to double bond CO carboxylic acid. Which is the best reagent for oxidizing this? So let's see, we have here double bond and COCH3. Try to see this one carbon in the final product is less, and here this ketone is oxidized to carboxylic acid. See, only one reaction we have seen where ketones can be oxidized to carboxylic acid, that is in haloform reaction. In haloform reaction we have seen this. Okay, we should use NaOH plus iodine for iodoform, and this NaOH and iodine will give you NaOI and NaI plus water. So this NaOI will go and react as a form of reagent from iodoform reaction. Now see, this is a methyl ketone, and this methyl ketone will be oxidized to carboxylic acid. Always remember, whenever we have a methyl ketone, this all the hydrogens are replaced by iodines. All the hydrogens are replaced by iodines, and we will get CHI3 as iodoform. And this ketone will be oxidized to further by a carboxylic acid. So two things you will get, one carboxylic acid, other iodoform. So according to this, answer should be B correct. Try to see this question, it is simple. Chromic acid cannot oxidize ketones. Copper at 300 degrees Celsius will also oxidize double bond, and KMnO4 also will oxidize the double bond. So you should use any specific reagent which will oxidize only ketone, not the to carboxylic acid. Next question, see. Here we have a carboxylic acid. We put lithium aluminium hydride, PbR3, KCN and water. Hydrolysis, acidic hydrolysis is given. So let's see, first draw the structure of the reactant. Here we have carboxylic acid. Let's see, lithium aluminium hydride with water. Work up with water we do. Will convert this carboxylic acid into alcohols. So you will get CH2OH here. So this carboxylic acid will be converted to alcohol, and water will be using as a workup reagent. Then we have PbR3. From alcohol to alkyl halide, we can always use PCl3, PbR3. So for bromide, see, this alcohol will be converted to Br, alkyl bromides. And further you have KCN. KCN in DMSO. DMSO is a polar aprotic solvent, and KCN will attack by SN2 mechanism. It will attack on this carbon and Br is removed. So this is an SN2 attack. Try to see. So answer should be CH2, Br is removed, cyanide will come. And finally you add water in the presence of H positive, and heating you do. This is known as hydrolysis of cyanide. So what will happen? Hydrolysis, acidic hydrolysis will happen, and you will get CH3, CCH3, CH2, and this cyanide will be broken, all bonds will be broken, and will make carboxylic acid and ammonia. Remember or not, this is a simple question. You can convert first carboxylic acid into alcohol. Alcohol will be converted into alkyl bromide, and KCN will convert into cyanides, and after hydrolysis you will get carboxylic acid. So answer according to this should be B. Check. Next question, see. In the following combination of reactants can be brought for the transformation. So see here above, bromide is converted to an ether, and this bromide is converted to carboxylic acid. And we have learned कि Bromo, if you have a bromobenzene, it should be converted to benzoic acid by only one method, which is Grignard method. So try to see, and Br also we need to convert to ether. So let's see one by one we will do. So first let's say we have CH2Br here, and down we have Br here. So one by one reaction करते हैं. So let's say first reaction I do with CH3O minus alkoxide, sodium alkoxide, and with alkyl halide will give only one reaction, which is for ether synthesis. For ether synthesis there is one reaction called Williamson ether, Williamson synthesis, Williamson synthesis, ether synthesis. So what, this is a example of SN2 mechanism. SN2, or you here it is SN1 because it is Br is going from benzylic carbon. So here oxygen has to come and Br has to go. So check this answer. At meta you have Br and above you have CH2O CH3. Then next answer, see, next reaction. So let's say this Br you need, above you calculated, this converted this Br into ether. Down see, here bromide is there with benzene. So first make Grignard using Mg in dry ether. You will get here Grignard reagent of the benzene. So Mg will come and sit between carbon and bromine. You will get Grignard reagent, and after Grignard reagent you add what, CO2. CO2 in acidic medium. See, CO2 in acidic medium only one. Grignard is negative, Mg positive. It will attack on CO2 and you will get carboxylate ion, and after H positive given, it will become carboxylic acid. So from Br you convert it to carboxylic acid, and from this above Br, which is on the benzylic carbon, you convert it to ether. So first you should do, according to this answer, correct should be A. Try to see. First Williamson synthesis, then magnesium in dry ether, and last is CO2. Attack of Grignard on CO2 will give you carboxylic acid. Next question, see. Phenol reacts with methyl chloroformate in the presence of NaOH to form product A. A reacts with bromine to form product B. A and B are what? So B, bromine reacted, C means bromine will come somewhere. So according to this, somewhere bromine will come, and methyl chloroformate we have to react with phenol. So let's draw our structure. Let's say this is phenol. I react with methyl chloroformate. So there we have OCH3 formate in the presence of NaOH. So first reaction which will happen here will be acid-base reaction. NaOH is a base, it will attack on the acidic hydrogen of phenol and will give you phenoxide ion. Now this phenoxide ion again will react with methyl chloroformate. Now try to see this methyl chloroformate, how it will react. O minus. Now see, this is an O minus. It can act as a good nucleophile. It will go attack on CO. O will become minus. O minus will come back. And from here you have to remove Cl and OCH3. And we have learned between Cl and OCH3 which is a good leaving group. Cl is a good leaving group. So Cl can go from here. So answer correct according to this will be, try to see, above O will come and O will attack on CO. So CO and OCH3 will be there. So first answer according to A. So this will be your A. Now further reaction is given. This A is reacted with bromine. Now if bromine, if I want to react with a benzene and above you have OCH3. Now try to see this group on the benzene and bromine you have to add. So now try to see, there oxygen lone pairs are there. This oxygen lone pairs will go and activate the benzene ring, and this oxygen lone pairs will go on and will try to delocate on this CO also. So this oxygen lone pair is not activating the benzene ring fully. So this is what? A weakly activating group. Now if it is a weakly activating group, bromine has to do ES reaction here, electrophilic aromatic substitution reaction. At which position? At ortho and para position. And from ortho and para also, para is the major product. So try to write the answer. So what answer we will get? Try to see. So here we will get something like Br will be at the para position of this group. ना Br will be at the मिथाइल फॉर्मेट ग्रुप के पैरा पोजीशन पे होगा. सो अकॉर्डिंग टू दिस आवर आंसर करेक्ट शुड बी सी ऑप्शन. ट्राई टू सी ऑप्शन. सी ऑप्शन में यहाँ पर आपका ये ग्रुप है एंड Br इज एट द पैरा पोजीशन. दिस ऑप्शन इज द करेक्ट. रेस्ट ऑल ऑप्शंस आर रॉन्ग. ट्राई टू सी. यही आंसर है आपका. चलो नेक्स्ट क्वेश्चन. ट्राई टू सी increasing order of pK values of the following. चलो one by one we will see. In this first one is a normal phenol. Now see here in B option we have NO2. We always know acidity order calculate, then pK value calculate. pK order you can calculate by first check acidity, then reverse will be pK. acidity का opposite is only pK. And for acidity always see कि electrons withdrawing group is directly proportional to acidity and electrons donating group will be inversely proportional to acidity of any compound. So try to see all are alcohols, all are phenols, all are aromatic alcohols, phenols. So all we can compare. So let's see in B option. In B option see NO2 is there. NO2 क्या करता? It is acting as -M group at para position. -M group means it is an electron withdrawing group, therefore acidity will increase. And in C option C, NO2 group is at meta, and at meta what will happen? -I effect only will happen. -M does not work at meta position. Remember, -M is not working at meta. Only -I inductively it will withdraw. So it is an electron withdrawing group. So it also acidity will increase, but it will not increase more than B because it is inductive. Inductive is a weak effect. Then mesomeric. And last OMe you have +M group at para position. So those who are electron donating group, they will decrease the acidity. And A, you know, A is normal, no increase, no decrease, it is constant. Hydrogen will not give nothing. So try to see from this A, B, C, D. So we will write first the acidity order. Acidity order will be highest acidic will be B, then it will be C, then it should be A, and last will be D, acidity order. And pK values will be opposite of acidity order. So B will be lowest, then C pK value, then A, then D. So BCAD. So BCAD is given in which option? BCAD is given in B option. Try to see. BCAD is given in B option. Try to check your answer. B option is the correct. Next one, see, specific conductance of this much is given to you of KCl. Here specific conductance of this much concentration is given, and here specific conductance your K is given to you. When a conductivity cell is filled with same solution, it offers a resistance 484 ohms, means R is given to resistance. If the same cell means it should have same cell constant, is filled with NaCl solution. If same cell is filled with NaCl solution at same temperature, gives a resistance this much. So R will become this. Calculate the value of equivalent conductivity of 0.0 mole NaCl. Equivalent conductivity means lambda EQ you need to calculate from where? For NaCl. For 0.011 normal NaCl you need to calculate. Now two cells were there, same cell they have used in two the cells, so their cell constant is equal. Now cell constant you know, it is L by A. Now cell constant they have given as equal. In first cell they put KCl, and second cell they put NaCl. In same cell they have used here resistance. Here K was 0.0014106 ohm inverse, centimeter inverse, and here resistance came out to be 484 ohm, and here K you don't know, and here resistance came out to be 5496 ohms. So what you need to do, try to see cell constant are equal. So you know cell constant from the value L by A will be equal to K equivalent conductance into R, and this equation you try to make. I is equals to rho L by A, then convert into conductivity and resistivity, and then you make out K and R from here. So cell constant means K into R is constant in both the reaction. So K into R of this reaction should be equal to K into R of this for NaCl and for KCl. Now try to calculate the K value for NaCl. So try to see 0.014106 into 484 is equals to K of NaCl into R is given 5496. So K of NaCl will come from here 0.00141106 into 484 divided by 5496. This you keep like this only, don't calculate. Now try to see. Now you have to calculate lambda equivalent. Lambda equivalent is K into 1000 centimeter cube divided by normality in gram equivalence. This formula you remember. Now you put K value, you came to know from here, K value you know. So you put K value here, and 1000 normality of NaCl is given to you. Normality of NaCl is 0.001 mole normal. Now you calculate from here. See, 0.0014106 divided by 5496 ohm. This is ohm. This will come centimeter inverse into 484 into 1000 centimeter cube divided by how many number of gram equivalents in 0.01 mole. If you take, it will be coming 0.01 gram equivalents. If you take 1000 centimeter cube 1 liter, you will have 0.001 gram equivalents. So you calculate from here lambda E cube, equivalent conductivity will come 124.2 ohm inverse centimeter square into gram equivalence power minus 1. Try to see answer will come according to this B. Simple question of equivalent conductivity. Just you need to find the K, and then you put the K to find the equivalent conductivity. Specific conductivity find, then equivalent conductivity. Next question, see, same question came in last exam. I guess it is repeated again. So like to see W is equal to ZIT, Faraday law. Faraday's first law. First law. How much amount will come is equal to Z. Z is equals to equivalent weight by F, Faraday, into current into time. And Z is equals to C, equivalent weight for monovalent atom is equals to atomic mass by n factor. So atomic mass, you know, atomic mass n factor is 1 for monovalent atom. So equivalent weight will equal to atomic weight. So here you put atomic weight by Faraday into I into T. Atomic weight you need to find. So W into F into I into T will give you atomic weight given 3 grams, Farad is 96500, and current is given 9.6, and 10 minutes convert in seconds, so multiply by 60, answer will come 50. Simple. Last exam also this came, I guess it is repeated. Next, see, depression in freezing point of this much solution is this: 1 molar urea freezes at this much. Assuming molarity equal to molarity, pH of this solution should be what? Now see, this is the question of depression of freezing point of solutions chapter. In this, see, one you have given acetic acid, other you have given urea. Delta TF is given in both the, and concentration also given. And for urea, you will know I means Ventop factor for urea is always 1, because urea will never dissociate. And I will be coming from this acetic acid, I will be coming Ventop factor. So I will come according to the dissociation constant. How many number of moles of ions will be broken by acetic acid will be according to the dissociation constant, and I will be number of ions in which it is broken. So let's see one by one. Let's calculate I from this. So delta TF is equals to KF MI. Then so what you do, delta TF of, you calculate urea, divide by delta TF you take for acetic acid. What you do, KF, you know, KF will be for both will be water only, because aqueous solution is given in both the. So aqueous for KF for water and KF from water above will cancel out into M into 1, and down it will be molarity of acetic acid into I. Now KF will be water 1.86, it will cancel out up and down, so no need to find KF. So delta TF for urea given, it is 1.86 given, and this is given 0.02. Molarity of urea, it is given to you, urea given 1 molar, and down it is given 0.01 molar, and I you calculate. So according to this equation, you calculate the Ventop factor for acetic acid. So it will come approximately 1.1. Now try to see, this acetic acid will break down into acetate ions in equilibrium with H positive. So initially let's say it is 1 minus 1 0 0, and finally it is 1 minus alpha alpha alpha. So at equilibrium, I Ventop factor will be 1 minus alpha plus alpha plus alpha. This is 1 plus alpha, so I will come 1 plus alpha, and I, you know, 1.1 I came, 1 plus alpha, alpha will come out to be 0.1. This is the degree of dissociation. Now if alpha came out to be 0.1, now you try to see how much H positive ions are there. So for 1 mole it is alpha, for C moles, for C concentration it is C alpha. So and concentration of your concentration of acetic acid was given 0.01. So what you do, you multiply 0.01 with 0.1 alpha, this will give you 0.001. Now this is the concentration of H positive ions in the solution after dissociation of this acetic acid. Now try to see, calculate the pH value. pH value is, you all know, minus log of H positive. Minus log of H positive is concentration of H positive is 0.0. So minus log of 10 power minus 3. Minus 3 will come forward, and log with the base 10, and 10 will give you 1. So answer will come 3. So answer according to this 58 will be B option. Now check next question. PTCl4 6H2O exists as a hydrate complex in aqueous solvent, has a depression point in freezing. This much depression given. Assume 100% ionization, means alpha is 1 and Kf is given to you. Then the complex is which one? So you need to see how much I Ventop factor is there. Now Ventop factor will tell you that if the salts are dissociated, how many number of ions they will give, because given 100% dissociation they will dissociate completely. So how many number of ions they will give? So one by one we will calculate. So Vent-Off factor by the solution depression of freezing point delta TF is equals to KF into MI. So delta TF is given to you 3.72, KF is 1.86 into molality. Molality is 1 molar, and I you calculate from here. So I from here will come 2. So means after dissolution of the salts, 100% ionization, you will get 2 ions. 2 ions will get only in option which? C. So see, in PT water, 3 ions, 3 Cl are inside this coordination sphere, and this Cl with 3H2. If I dissolve this salt in water, so we cannot break this coordination sphere, and it will be like this only, and only one ion will be Cl minus, and this will be positive. So total we have only 2 ions. Means Vent-Off factor here should be 2. So answer correct should be C option. Here Vent-Off factor is how much? 3. 1 for this coordination PS and 2 Cl are coming. Here Vent-Off factor will come how much? First option it should be 4 from Cl and 1 5. And here Vent-Off factor will be 1 because only coordination sphere is there. No outer ions are there. So I will come 2 for only C option is it. Next question, see. Lowering vapor pressure is highest for which one? Now lowering is vapor pressure is P0 minus PS upon PS is directly proportional to what? Number of moles of solute into Vent-Off factor. Now try to see, it is directly proportional to number of moles of solute into Vent-Off factor. Now see one by one which one will be having relative lowering highest. So relative lowering will be highest if molality concentration into I is also the highest. So one by one we will calculate. For 0.2 molar urea, how much CI we can do. So C is given 0.2, concentration into I for urea is 1, so this one 0.2 will come. Next one 0.1 molar glucose, this one will come 0.1 into 1, glucose is 1 Vent-Off factor, this is also 0.1. Now check 0.1 molar MgSO4. Now for MgSO4 Vent-Off factor 0.1 into 2 will come, because MgSO4 will have 2 positive and 2 minus, total positive and negative charge will be there in salt. This is also 0.2, and this one 0.1 barium chloride. Now barium chloride will have how many Vent-Off factor? It will be barium chloride Vent-Off factor will be 1 barium ion and 2 times of chloride ion. So 3 ions are there after dissolution. So here 3 ions you do, this will come. So highest CI will be for barium chloride. So therefore highest lowering of vapor pressure will be for D option, barium chloride 0.1 molar. Next question, check. pKb value you need to find for this solution, where lambda naught an infinite dilution given and lambda molar conductivity given, and here 0.1 molar concentration given for acetic acid. Now from this you know alpha, degree of dissociation. Whenever we have given these two both values given, try to find alpha. Alpha you know from this equation will come how much? Lambda m divided by lambda at infinite value by m. So this is given how much to you? 7.8 divided by 390. This will come 0.02. Now degree of dissociation is 0.02, means approximately 2% only. So 2% only dissociate. Now try to find the pKb. A pKb value, for pKb you should know the Kb or Ka value, and for Kb and Ka value, let's see one by one. Ka value we will calculate for acetic acid. Ka value we will calculate for acetic acid will have Ka value because it is an acid, weak acid. We'll have Ka value, we'll have pK value, and pKb you can calculate whenever we have pK plus pKb is equals to pKw. pKw you always remember, it is always 14. So now check for Ka value for acetic acid how we will calculate. So Ka will be equal to what? C concentration is given to you, alpha is given to you, concentration is given to you. K for acetic acid will be C into alpha square upon C into 1 minus alpha. Now C and C will cancel out from here. So C into alpha square and 1 minus alpha. Because alpha is very less than 1. So we take this approximate value as equal to C alpha square. Now C is given to you 0.04 moles. And alpha you calculated 0.02 square. This will come approximately 1.6 into 10 power minus 5. Now K you know, pK value you can find from K minus log of K. This one will come log of 1.6 into 10 power minus 5. This much will come 5 minus log 1.6. And log 1.6 value we have given to you. This one will come 4.8, approximately 4.8, approximately 4.79 something, but you take 4.8 from here. And from pK value no, pKb will be plus pK is equals to 14, and pKb will be 14 minus pK. This one will come 14 minus 4.8, approximately equals to 9.2. So answer will come yours 9.2 for acetic acid. So in this question you calculate alpha, then from alpha you calculate Ka, C alpha square, directly you know, if alpha is very low, C alpha square. Now if you know Ka, you can calculate pK and then you can calculate pKb. Simple. Next question, in this question see, this option it is made as none of these. For this, standard electron potential of Ag to Ag positive and metal insoluble salt anion are related as. So this electron potential you should know whenever we convert Ag to Ag positive, and here we have Ag, AgCl and Cl minus, metal insoluble salt anion. This electrodes you should know. So let's see, for this reaction at cathode with what will happen. At cathode AgCl will reduce itself to Ag and Cl minus cathode, and at anode what will happen? Positive electrode. At anode what will happen? Oxidation will happen at anode, loss of electron will happen at anode. So according to this, full reaction will be, according to this will be Ag, Cl is converting into Ag positive and Cl minus. Now try to see for KSP. For KSP, this reaction should be at equilibrium. Equilibrium reaction means E cell of the reaction should be 0, and E naught cell will be E naught reduction minus E naught oxidation. And you all know reduction will happen at cathode and oxidation will happen at anode. E naught cathode minus E naught anode. So E naught reduction, let's see, will be E naught Ag, AgCl and Cl minus, and E naught oxidation will be Ag to Ag positive. This is the E naught cell value. Now from Nernst equation you know E cell is equals to E naught cell minus RT by NF log with the base 10. ln with the base E, product divided by reactant. Now product concentration, product concentration will be Ag positive into Cl minus. This is only the KSP divided by AgCl is always solid, so you take 1, AgCl concentration you take 1. So now this value, it is known as KSP value. So from here E cell will come out to be E naught cell minus RT, number of moles of electrons are 2, so you write 2F. Number of moles of electrons are only 1, so 1 electron is changed in this reaction, so here 1F will come and log of KSP will come. Now this option, try to see where it is given. Some misprinting is done in this option. So what you do, this option, B option, it should be correct. This will be given to you by your teachers. So E cell will come out 0 from here. So E naught cell will come out RT by F ln of SP. And E cell from here, E cell will be E naught Ag of AgCl, Cl minus of E naught of Ag positive will give you RT by F ln of KSP, solubility product. Now from here you calculate E naught Ag of Ag Cl minus will give you E naught of Ag and Ag positive electrodes plus RT by F ln of KSP, and this is the equation for this. This will be the equation for this and answer for this. So according to this, answer should be this correct. And this is given in option, which answer is given in option number B. So this correction you do in the question paper only. This should be the answer. Next C63 question. Let's say here we have carboxylic acid and down you have CS2CHO. Now NaBH4 will convert aldehyde into alcohol. So here you will get carboxylic acid and here you will get CS2. So this aldehyde will be converted to alcohol. Now this is known as A, and after you provide H positive and heating, some cyclic product will be there. Try to see this reaction, which this reaction is called what? This reaction we have an alcohol and we have a carboxylic acid, and this reaction will be esterification reaction. In the presence of acid, we will do ester can be formed and you will get something. So from here hydrogen remove, from here OH remove, and from here H remove, and try to make an ester. So CS2 and oxygen will come. So here you will get a cyclic ester, and this option is given in only which correct? A correct. Answer is A. Next question we will jump. Next question, see. Here this ester is converted to amide. So how we will convert this ester to amide? Let's see one by one. So let's say we have a CS3 here. I will draw once again CS3. So first you you do hydrolysis first. Hydrolysis of ester will give you what? Carboxylic acid and alcohol. Saponification reaction. So here you will get one carboxylic acid, and this OH will form break from here, and you will get your carboxylic acid and alcohol. Then you convert this alcohol into acid chloride. So once this acid chloride came, then you can make your amide by acetylation. So this OH will be converted to Cl, acid chloride, from carboxylic acid to acid chloride. Now further what you do, so here CH3 is used, so what you do, CH3 NH2 you use. So what you do, acetylation you do, hydrogen and Cl you remove from here, nitrogen will go attack on CO and Cl is removed, and you will get your amide. So here CH3 there, and here you will get your NH and CH3. So this amide, cyclic amide, you can get by this method. So answer according to this correct should be A. So first do hydrolysis of ester hydrolysis, then you do a SOCl2, and last is what? Acetylation of amines, and then you can get your amides. Simple question. Next, see this question. See, if you have not done Friedel-Crafts reactions, try to write Friedel-Crafts reaction by yourself. This mechanism is utmost important for you. Try to see this mechanism, how we will write this mechanism. So let's say AlCl3 we are giving as Lewis acid. So this oxygen will go and give lone pairs to AlCl3 by Lewis acid and Lewis base interaction. So what you will get, this cyclic, and O will try to donate its lone pair by coordination bond to AlCl3, and always coordination bond we can write it like a covalent bond, and negative and positive we can write. Now try to see this one. Now this lone pair will go and will donate, make this oxygen as resonance. So यहाँ oxygen के ऊपर positive, you donate the electrons to positive, and you will make this like this. एक ऊपर से इधर ये वाला electrons will jump this side, these two electrons will jump this side, and then these one will jump this side, and down it will come. Sorry, I will draw again, wait. See, this is a concerted mechanism, एक साथ लिखना आना चाहिए. So from here you make here, and this bond you break, and this will be made double bond. This single bond will shift here this side, and this double bond will be made single bond, and electrons will come on oxygen. So above you will make asylum cation, and this reaction is called Friedel-Crafts acylation reaction. So यहाँ पर तो asylum cation बन गया, positive will come here, asylum cation बन गया. Now see this asylum cation, down you will get what? C double bond O 1, and you have O and AlCl3, O AlCl3. Now see, now benzene electrons will go and attack on asylum cation to give you 1, 2, 3, 4, 5, 6 membered ring with this. So you will get 6 membered ring something here. So try to see this, how I will write this 6 membered ring. So here I write 6, here I write 5. Try to make this first. 6 membered ring make 4, 3, 2, 1. So at 1 this will go attack, and O will become again CO. So at 1 you have CO, 2 will be CH2, 3 at 3 you have CO and O AlCl3. And after the workup of this reaction, acidification of this reaction, you will get something, product will be like this. So here you will get carboxylic acid and above you will get ketone. So answer will be this, and answer given in the options will be B. Try to see this question, simple it is. Next one, see which of the following compound undergoes decarboxylation. Always remember beta keto acids undergoes decarboxylation easily. So whenever you have a beta keto acids hota, if you have this beta keto acids, this will go, this CO2 will run. Decarboxylation means loss of CO2. This oxygen will break and this double bond will come, and this will come as like this. So here you will get first enol, and after tautomerism you will get back your, after tautomerism you will get back your keto form, cyclohexanol. So answer should be cyclohexanol. Which one will give? So answer 3 will give easily, because see, this is alpha, this is beta. At beta you have keto, so beta keto acids can give. This one try to see, this is an ester and CO for ester, keto acids. So this one is alpha, it is beta keto ester, not acid. This one also see, this is both carboxylic acid at alpha and beta. So at beta keto you should have there. For this carboxylic acid this is alpha beta, and here at beta no keto is there. And here also see, for CO and CO this is very far, CO2 cannot be removed. So answer will be 3 option. So only beta keto acids. Remember, whenever we have beta, at beta you have, let's say this carboxylic acid, this is alpha position, this is beta position with respect to COH. Therefore beta, if you have keto acids, this will make 6-member transition state and CO2 will remove. Remember. Next check question 67. In question 67 try to see. Here ferric ammonium nitrate test is given to you. Ferric ammonium nitrate test is given to you. A molecule, this C3H6O, undergoes Grignard reaction using methyl magnesium bromide. Always remember, whenever you have a aldehyde, it will make 2-degree alcohol, and if you have a ketone will always make 3-degree alcohol after Grignard reaction. Done. And first test we do for C and D will be ferric ammonium nitrate test. Ferric ammonium nitrate test is for alcohols. CN test, CAN test, ferric ammonium nitrate test for alcohols. Next test is Lucas test. Lucas test is for distinguish of 1 degree, 2 degree, and turbidity after 5 minutes means it is 2-degree alcohol, and turbidity obtained immediately means it is 3-degree alcohol. Last is iodoform test. Iodoform test, whenever we have positive means it should be a methyl ketone something alcohol. So इसका ऑक्सीडाइज होता तो मिथाइल कीटोन बनता, और ये नेगेटिव दे रहा means it cannot be oxidized. Iodoform it cannot give, and it should be 3-degree alcohol. So something 3-degree alcohol should be there. And see this one, try to see, this should be something like this. So option correct according to this will be which one? This is 2-degree alcohol, this is 3-degree alcohol. So C should be what? C I will draw here. C देखें, C here, C3H6O. Here degree of unsaturation will come 1. dBe you calculate. From here, if I have these two compounds are there, if we have an acetone as a compound, and here we have propanol aldehyde. In this, if I do Grignard reagent, this is called B and this is what? A. If in this, if I do Grignard reagent, I will get 3-degree alcohol. So here I will get CH3, CH3 and OH. This is your D. 3-degree alcohol is your D. And if I do here Grignard, CH3 MgBr, this one will go attack and OH will form. So CH3, CH2, COH and CH3. Now this is 2-degree alcohol and this is C. So C and D you came to know, A and B also you know. So So answer according to this should be correct, A option. C is a 2 degree alcohol and D is a 3 degree alcohol. Next check option. Delta G value given to you, standard voltage are obtained from ethane, fuel cell is given to you, C2H6, and oxidized using oxygen, you will get CO2 and H2O. Delta G gives free energy is given to you, standard voltage that can be obtained. Voltage means you should follow the E0 cell value, calculate for this. Delta G and E0 cell, you know, delta G naught is equals to minus NFE E0 cell. This is the equation you can calculate using. So delta G value is given to you, E0 cell you need to calculate. Number of electrons which are passed through the solution, now you need to calculate. Now try to see, C2H6 is converted to CO2. Here the oxidation state on carbon will be -3 and here it is +4. So change in oxidation state will be how much? 7. But for 2 carbons it is how much? 2 into 7, which is equal to 14. And this 14 is the n factor of this reaction. N factor is equals to 14. That many n factor is equals to number of electrons. Number of electrons which are exchanged in the reaction. In this redox reaction, number of electrons which are exchanged in the reaction. So number of electrons will come how many? 14. So now you put all the values and try to find the E0 cell. So E0 cell will come, voltage from here will come, how much voltage will be? Minus delta G naught by NF. Now delta G is given in kilojoule, convert in joule, minus 1467 into 10 power 3 divided by N is given 14 and F you know 96500 coulombs it is. So this one will come minus and minus given, earlier also one minus is there, so minus will become plus. So E0 cell becomes something plus 1.085 voltage. So try to calculate, simple question, answer will come D. Next, see molarity of nitrate ion in the solution. If 2 liters of 3 molar AgNO3 is mixed with 3 liters of 1 molar barium chloride solution. Now see, AgNO3 reacts with barium chloride to give you AgCl and barium nitrate. Now try to balance this reaction. Here 2 will come. And here also 2 will come, 2 and 2. So 2 moles of AgNO2 will react with 1 mole of barium chloride to give you 2 moles of silver chloride and 1 mole of barium nitrate. So now this, in this see, 3 molar it is given, 2 liters it is given. And this also barium chloride 3 liters it is given, 1 molar if 3 liters it is given and 3 liters it is given, 1 molar it is given. So here number of moles you calculate, molarity into volume, 3 into 6 will come 6 moles, and here how many? 3 moles. So 2 moles react with 1 mole of barium to give you 1 mole of nitrate. So nitrate ions concentration you need to find, molarity of nitrate ion you need to find. So 2 moles react with 1 mole to give you 1 mole, and 6 moles of AgNO3 will react with 3 moles to give you how many moles of barium nitrate? 3 moles. 3 moles of barium nitrate will be formed. Done. From here 3 moles. Now see, barium nitrate itself, 1 mole of barium nitrate gives how many moles of NO nitrate ions? So 1 mole of barium nitrate, you see, 1 mole of barium nitrate will try to give you 2 moles of barium nitrate. So 2 moles of barium nitrate बने आपके, 2 moles of barium nitrate बने. So means 1 mole will give you 2 moles of barium nitrate. 3 moles will give you how many? 3 moles of barium nitrate will give you 6 moles of nitrate ions. Now 6 moles of nitrate ions are, you know, so molarity is what? Number of moles divided by volume of solution. Number of moles, you know, 6 moles of nitrate. Molarity of nitrate calculate from here. Divided by volume. Volume total will be 3 moles is added in 2 moles is added in 3 liters. Total volume will be 5. So 6 by 5 will come how much? 1.2 molar. So answer correct will be B. Last, see next 70th question. Aqueous solution freezes at this much. What is the elevation in the boiling point if Kf and Kb is given to you? So here freezing depression in freezing point is given, Kf is given. So same solution, one time you freeze and other time you boil. Elevation in boiling point you see after addition of your solute, non-volatile solute, how much elevation in boiling point and depression in freezing point. So here delta Tf you know, and here delta Tb you know. So from here you know delta Tf is equals to Kf into m into I. I will be how much? 1 only take. If not given to you, take 1 only. And here delta Tf is equals to Kb into m into I. Now molality you don't know in both the solutions, but delta Tf, Kf you know, and delta Tf you know. So from delta Tf and Kf you calculate molarity, and you keep this molarity into this equation, and then you calculate your elevation in boiling point, delta Tb you calculate. So what you do, delta Tf is given 0.186 is equals to Kf is given 1.86 into molarity. So molarity will come 0.186 divided by 1.86. This will come 0.1 molar, and this you keep in here. Delta Tb is equals to 0.512 into 0.1 into I you take 1. Whenever it is not given, take 1. This will come 0.512, and answer will be this much elevation. This is the elevation at boiling point. Aqueous solution given means it will boil at 100.0512 degrees Celsius. Chale. So with this we have done all our MCQ. Now we will jump to NAT. First question, see, mole fraction of solute in 1 molar aqueous solution means 1 molar aqueous solution is given. Aqueous solution means water is the solvent and solute is 1 molar. So molality is equal to number of moles divided by volume. So let's say 1 molar means 1 mole is there in 1 liter of the solution. 1 liter I'm saying, molality it is there. So this will be 1 kg of solvent, 1 kg of solvent, or you can write 1 kg of solvent as 1000 grams of solvent. Now you need to calculate the mole fraction of solute. Now mole fraction of solute will be number of moles of solute, which you know it is taken as 1 mole, number of moles of solute, number of moles of solute plus solvent. Total number of moles will give you the mole fraction. So number of moles of solvent you don't know, number of moles. So number of moles of solvent, how you will calculate? Given mass, which is given 1000 grams. Molecular mass of solvent is 18. So 1000 water only is the molecular mass. 1000 by 18 will come 55.55. This value remember always. This is the number of moles. So what you do, number of moles of solute 1 given, number of moles of solute 1 divided by plus 55.55. This one will come 1 upon 56.55. This is coming approximately 0.177, and for round off you will write as answer 0. So answer will be 0 of this, though it cannot be 0 but answer will be 0 according to the round off. Round off अगर इसका करें भी तो it should come 0.02, and you cannot write the 0.02 in your answer keys, therefore answer will come 0. Next question, see 72 question. Moles of sodium hydroxide they have asked you, present in 2.5 liters with 0.5 molar. Simple question. Number of moles is equals to molarity into volume. See, remember, if volume given, if volume is in liters, you will get your moles. If volume is in ml, you will get your millimoles. And if moles are asked, convert. So here number of moles will be molarity 0.5 molar and volume given 2.5 liters. So here moles will come. So answer will come according to this will be 1.25. And you round off this value, answer will come 1. So this numerical answer type, answer will be 1. Next question C. How many of the following undergo decarboxylation on heating? Always remember, check beta keto acids. And some exceptions are there also. Check by beta keto acids you need to check. So for this carboxylic acid to remove, this is alpha position, this is beta position, and at beta you have a ketone. So this one will do decarboxylation, CO2 will go from here. This one check, this is carboxylic acid, this is alpha, this is beta position, and here at beta no CO is there, so this one will not undergo. This one check, then this one check, COH, here it is alpha position, here you have beta, at beta you have CO, the CO you have at beta, so this one will also undergo. And here also check, this is alpha beta, and beta you don't have CO तो नहीं है beta पे, so this one will not undergo decarboxylation. And here also this is 2 carbons alpha beta here only, where also it won't undergo. This also see, this is carboxylic acid, this is alpha beta, and at beta you have CO, this also will undergo decarboxylation. This one try to see, this is alpha beta, but this one at beta you have a ketone, but this one will not undergo decarboxylation. This is an exception, try to learn this one. Try to see here, if I have COH and CW, so here it is not in a plane, so that we can make a cyclic 6-member transition state and CO2 can remove from here, and it will break one rule which is known as Brett's rule. Understanding or not? So here double bond we cannot make, here. Enol first we will make, enol, by removing of CO2. So here double bond we cannot break, and Brett's rule will be violated by this method. So we cannot break the Brett's rule, therefore this decarboxylation CO2 we cannot do. So this answer option will be wrong. How many of the following will undergo decarboxylation? So 1, 2, 3. So 73 answer should be 73. Question answer will be 3. Only 3 will undergo decarboxylation. First one will be this one, second one will be this one, third one will be this one, and 3 only will be there. Rest won't undergo. This question you try to see yourself, discuss with your teachers also, again they will tell you. Which of the following reaction produces benzaldehyde? So these all reactions are preparation of benzaldehyde. First one, see, this is known as Gatterman-Koch reaction. Gatterman-Koch reaction. In Gatterman-Koch reaction you will get your benzaldehyde. And second one, this is 2Cl are there, 2H2O will go and attack, you will get again one benzaldehyde, side chain chlorination, water will remove from here. S2PDBSO4, let's see this one, S2PDBSO4, here missing part is this one, try to see, acid chloride again, this is known as Rosenmund reaction, and this will also undergo, and here you will get benzaldehyde. And last one, see, this is an ester, and ester if I reduce using dibyl H can reduce ester into aldehyde, and this also will give you benzaldehyde. So all the 4 options will give you benzaldehyde. This correction is there in your question paper, try to see, answer will be 4. Last one, question C, fraction of iron present in Fe3 positive in the electrons, how much? So this cell is given to you where zinc is converting to zinc positive, Fe3 is converting to Fe2 positive. How many fraction of total ions? Fraction of total ions you need to see. So fraction will be equal to what? Fraction will be equal to how many ions of Fe3 positive ka fraction will be Fe3 positive ions divided by total ions. Total ions will be Fe2 positive also and plus Fe3 positive also. So this one you need to calculate. And from here cell potential E cell is given to you. E cell is given to you. E naught cell you can calculate from here. Now try to write the Nernst equation for this. See, Nernst equation, try to write Nernst equation. Nernst equation, let's say Fe3 positive plus electron is converting to Fe2 positive. And next reaction, see, zinc solid is changing to zinc 2 positive plus 2 electrons, and here E naught cell is given 0.77 voltage, and here E naught cell is given 0.76 volt. So you do what you do, you need to reverse this reaction. This is given in minus, you need to plus it. So total E naught cell will be 0.77 plus 0.76. This will come approximately 1.53 voltage. E naught cell you know, and now you know E naught cell you know 0.13. Now E cell will be equal to E naught cell minus 0.059 divided by number of electrons which are involved are 2 electrons, log with the base 10, product divided by reactant. Product you have Zn2 positive, and in the product you have Fe plus 2 ions, and power 2 is there. Down it is Fe plus 3 ions, power 2 it is. Now E cell it is given to you 1.5, E naught cell is 1.53, you calculated 0.059 by 2, log with the base 10. Zinc is given to you how much? 1 molar, and iron, this you need to calculate. Fe plus 2 power 2 divided by Fe plus 3 whole power 2 you take. This one, see, this one will come 0.03 into 2 divided by 0.059 will come log with the base 10 into Fe2 positive concentration divided by Fe plus 3 concentration power 2. So try to cancel out these things. This will try to see. This one will come how much? So log with the base, this will come 1. This you take 0.06 only. So here 1, 2, 2 and 2 will cancel. Log with the base 10 value will come. This all thing will come 1, and this all thing will come only whenever you have Fe2 positive by Fe plus 3 power 2 is equals to always 10k, but Fe3 positive by Fe2 positive will come 1 by root 10. So you take Fe3 as 1, Fe2 positive as root 10. So calculate this fraction of how many Fe3 positive were there. So you calculate this fraction, this will come out to be, this one is 0.316. If you take Fe3 positive as 0.316 and Fe2 positive as 1, so Fe3 positive is taken 0.316 and Fe2 positive is 1 plus 0.316. This one will come 0.316 divided by 1.316, and this, if you try to solve this, this one will come 0.24, and answer will be 24 into 10 power minus 2. So 24 answer you need to write for this question. So with this we have completed our solutions. So thank you all. Bye bye.